All right, Tom and I are here in the Canary Islands, and when we're at the beach, there's nothing I'd rather talk about than kidney cancer biomarkers. Ever since I was a child, going to the beach, I've been talking about kidney cancer biomarkers. So, Tom, you made a slide, which hopefully should accompany this, that looked at the state of mostly tissue-based biomarkers in metastatic kidney cancer. Give us a brief description of what that showed.
So the slide summarizes all of the previous trials that we've done with the VEGF-TKI versus VEGF-TKI-IO and the Ipi-Nivo trial. Then all of those trials had a positive overall survival signal. And all of those trials have done DNA, RNA, and protein analysis. And all of those trials have done essentially inter-arm analysis, looking for good or poor outcome with sunitinib or the study arm.
Yeah.
And there's been some differences in the study arm. Clearly, avelumab is a PD-L1 inhibitor on the PD-1 inhibitor, and Ipi-Nivo is completely different. But we've shown a real lack of consistency across these trials. So the original trials, the bevacizumab and atezolizumab studies, show some things, some things like the T effector signature working, but then in the clear trial, that T effector signature didn't seem to work.
I think it's important to say that when the different trials are testing these signatures, the signatures are not identical. They're not identical.
Well,
I think they're very similar, but they're not identical.
Some of the gene signatures haven't been used, they've been published. So people have tried to make the same gene signature.
They've tried to make the same, but it's not identical.
It's not done in the same time. I agree to some extent with that. And T effector signature came up in all the trials except for one. But there isn't any single biomarker consistent for immune therapy response. And then crazy things like Ipi-Nivo, the angiogenic signature comes up and seems to be working, and that doesn't feel right either.
Well, I'll say two things. One is, I think it's easier to predict a response to single agent VEGF-TKI.
Yes.
Right, and we've gotten good at that over 20 years for what it's worth.
Yes.
Predicting response to immune therapy, I think, is likely more complex. And,
yes.
And obviously when you're combining mechanisms, it becomes even more complex.
And I accept it's become complex. Let me come back, if I may. But sunitinib was our original drug. We never did biomarker work for sunitinib against interferon back in the day. And that was a mistake, because we never really worked out who the sunitinib response was. There's a lot of difficult to work out what is predictive and not prognostic. Because we don't know with interferon or no treatment who the winners and losers are. Now we've learned a little bit from the adjuvant trials in that respect. And that's why I think the adjuvant trials are an important role to play. But just before you come in, one of the things we have shown is the angiogenic signature in sunitinib within arm.
Yeah.
If you have an angiogenic signature, it does seem to be associated with outcomes sunitinib. The other strange thing, c-MYC mutation or MYC mutations seem to be associated with poor outcomes sunitinib. And that was unexpected. And indeed, I would argue that we've actually got better biomarkers now for sunitinib with all these experiments than we do with immune therapy. It's all over the place.
I agree with you. I would say, I don't think DNA alterations have much of a role as a biomarker. That's my opinion. The fact that c-MYC associates in some studies, it's just reflective of a proliferative tumor, right? So that wasn't surprising to me, or I'm not sure if it looks that clinically. The RNA-based signatures, I think, are much more promising, and I think what we've seen is, yes, it's easier to predict response to sunitinib, and it took us a long time to get there. They're also prognostic, right? Angiogenic tumors are more indolent tumors, endocrine mets. The very good risk we may talk about in other settings. These are all angiogenic driven. Those are just better prognostic tumors. So to your point of separating predictive and prognostic, it becomes very difficult when you have an anti-angiogenic agent, right, as part of your agent.
Brian, one of the two interesting studies that have come out recently, I'm going to say three. First, the work that Sam has done at the CRIC is fabulous. And then VHL mutations, and then the acquisition of PBRM1 and other mutations, and that does seem to be prognostic and associated with different patterns of kidney cancer. We haven't got time to describe the detail of those papers, but they're worth a great read. They may not be predictive biomarkers, but it does tell us about this branch evolution, which I think is important. Other work, David Braun's work and others, which we've done podcasts on recently, looking at the Ipi-Nivo deep responders. It may be better actually not to look at the median values, above or below median OS, but just get that. Who are the absolute Ipi-Nivo winners?
Yeah, it's on the tail.
Yeah, and that work, I think that work was interesting because that did show very different biomarkers. It may be that those are the important biomarkers. And there were things like neoantigens and enablements of things like TMB and piece of that.
Yeah.
So I think we did a podcast on that for the whole, and I think that's really important.
A couple other things. PD-L1 has been a very inconsistent biomarker and is not useful, and we should stop looking at it.
Well, let me not push back. Let me just say one thing, if I may, on that.
Please.
It's one of the things which we're going to talk about at the Canary Islands meeting. PD-L1 is not a biomarker. It is 3 different biomarkers. You've got PD-L1 immune expression,
Right.
the PD-L1 tumor cell expression, and the combination of the two. And the 3 behave very differently. This is different between a bus and a tree, or a beach in Spain and a beaches in the UK don't really look like this.
Yeah,
by the way. It's that different.
Not in Nashville either.
So we need to drill down on those different biomarkers. Now, there was some positive data for the TC biomarker with Ipi-Nivo in the 214 trial. Now, there was a lot of negative
I was
data.
going to say, you can pick out one
No,
positive
of course you can.
signal.
Of course you can. But there is a study, KO1, comparing the two, and I think it's a good question to ask. But I have to say, my preference in bladder cancer, as you know, is to drop the biomarker again. It's really been misleading. We need to be.
This is kidney cancer. Focus on kidney cancer.
No, I know that. But I was going to say, in kidney cancer, the PD-L1 story has been very, very consistent. And I agree with you, but it's not PD-L1. It's
Understand. Last thing, we'll wrap up. Where do we go from here? How do we move the field forward to clinically actionable biomarkers? Are we?
Well, you and Monty and Laurent and others have done some fabulous work on Kim1, and we did a podcast recently on that. Do you want to talk a little bit about our podcast, and who it was with, how it worked?
So Kim1's a serum glycoprotein, actually plasma, I think, measured in plasma. Seems to be easily measurable. There's been a number of studies, mostly in the adjuvant
I haven't
setting,
got any sun cream.
look at prognostic and predictive role. There was some data at ASCO GU from Vincent Chu, who we did a podcast with, looking at the Checkmate 214 data.
Vincent's done great work.
Yeah, he's doing really great work. And looking at early declines, I think it was at week 3 in Kim1 that really seemed to segregate out the responders. We have somebody passing by in the background. Fantastic. So I think it's really exciting. Again, it's easily measurable. It's serum, so that, it's not a fancy RNA test, just a serum blood test. Maybe it's too simple, but I think that's going to be one way of the future. And then, of course, prospective studies. We're doing one, others are doing them. These are really hard to do, but really important. Even if they don't show, from a clinical perspective what we want, we've got to set up the operations to do metastatic biopsies, to do sequencing, to do what we need to do. Otherwise, we'll be debating these retrospective data sets forever. The retrospective analysis.
We did a podcast 2 years ago with a chap who won a Nobel Prize, if I remember correctly.
We did, yes.
And I got hammered in that debate. I think that was based around reputation.
I think it wasn't not a fair fight.
Yeah, but at that point, I was saying that my feeling was that we had reached a plateau with new drug development, and actually we had to develop biomarkers. And that without biomarkers, we're going to struggle to move forwards. With hindsight, when you look back 2 years now, was I right? Did we plateau with negative Cosmic 313 trial? No overall survival with the HIF1 inhibitor, belzutifan. HIF2 alpha, probably. I think it's Kim1. The HIF2 alpha. Do those trials are coming? We haven't. The IL-2 study was negative. We haven't seen a plethora of positive trials. In fact, more negative trials than positive trials.
That's
and
fair.
We now have found a biomarker called Kim1. So was I right, Brian?
All right, I'm going to declare you the winner over Bill Kalin in that debate. Bill, if you're listening, which seems unlikely.
Very unlikely.
Yeah. Anyway, I think I think we've done a much better job developing biomarkers in this era of phase 3s compared to the previous one. Not perfect, not perfectly consistent, but I think we're going to get there. I think we're going to get somewhere soon. Let's put it that way. All right, final word.
Let's look at other tumour types and learn from what happened here. When we do develop new practice-changing drugs, instead of saying, we don't need biomarkers because this is for everyone.
Yeah.
Let's look to the future and say, one day we'll beat this. If we do beat this, then biomarkers are going to be really useful. That, for me, is the learning lesson we've had.
Thank you, everyone. Signing off from the Canary Islands.